our probability unit, and we're just combining what we did yesterday with probability. Yesterday we just discovered our counting rules to figure out how many total outcomes were possible. Now we're going to use that idea to help us find some probabilities. Before we get into the probability piece, though, in part one, just a refresher on what we did yesterday, or just kind of a piece of it, I should say. So we have in a company, we have 7 executives. We have 4 women and 3 men. 3 are selected to attend a management seminar. Find the number of ways selection can be done, and then we have a few different instances. So if we are just, here's what we have to think about first. If we are just selecting, so 3 are selected, find the number of ways selection can be done. We're just selecting. Are we putting them in any special order? No. Are we choosing different places for them to go? Like, hey, you go to the conference in Miami and you go to one in Boston and you go to one down in Dallas? No, we're not sending them anywhere special. We're just selecting 3 of them. So if I'm just selecting 3, are we going to use combinations or permutations? If I'm just selecting, combinations. Combinations are when I'm just selecting. We're not doing anything special with them. So if all 3 selected are women, all 3 selected are women, how many women do we have? How many women do we have? 4. You guys just said combinations, right? How many women do I need to select? 3. Now, there's also a group of men. So I know some of you are like, Miss Callie, why isn't that a 7? Why isn't it a 7C3? Because I want to choose 3 out of my 4 women. How many men do I need? We're selecting 3 total. How many men do I need in situation A? I don't need any men in this situation, but just so we can wrap our heads around, Miss Callie, there's 7 total. Why aren't we selecting from the 7? This is our women. And we can show the men also. I have 3 total men, but I don't need to choose any of them. 3 women, and I'm going to use one of our key words here, and 0 men. Keyword and means we're going to do what? Add these 2 or multiply? Keyword and, multiply. So go ahead, take them in with your calculator. See if you can get you should come up with 4. Then I want to give you a few minutes to play around, see what you can come up with for B, C, and D. So it's going to be a similar kind of setup to letter A. Thinking about how many women you need, how many men you need. We're just selecting them. We're just selecting, so it's going to be combinations. See what you can come up with. Also, use that calculator. Make sure you're familiar. I don't want you guys to have to do all the plugging and chugging of the formulas. You guys have the technology piece. I would use it. And some of us were just kind of sitting and waiting on C and D. So I'd ask you at the very least for C and D, write down what at least 2 men would mean. Write down at least what 1 woman means. So what situations do we have to consider for those? So let's start with B. A lot of us seem pretty confident with B. I'm going to keep things in the same order. I'm going to put women, and then I'm going to put men, just so it matches off of what we did in A. So I'm going to look at my group of 4 women first. If we need exactly 2 men, how many women do we need? We just need 1 woman, right? So out of the 4 women, I need to choose 1 of them. Out of the 3 men, I need to choose how many? I need to choose 2. I want both of these things to happen. I need 1 woman and 2 men. So we're going to multiply that together. I need both of those to happen. When I need both, we have that keyword and. We're going to multiply those two together to get what we need. So we should end up, if you did the stuff in your calculator, you should end up with 12.
Oh, yeah. Mail time.
You should end up with 12. Now in letter C, again, I know a lot of you are just kind of sitting and waiting. I want to see what Miss Golly does first. Just try it. There's a whole bunch of empty space on the sheet. If what you tried didn't work and you don't want to erase it all, you can cross it out. Try it and see what you think. At the very least, I said, write down what at least 2 men means. What does it mean? 2 or more. So in this situation, that means 2 or more. So if we have 2 men, we need 1 woman, 2 men. Or we need 2 women and, 0 women. 3 men, right? So that's what at least means. You guys said 2 or more. And now I know some of us are thinking, Miss Golly, how do we know we stop at 3 men? How do we know we stop there? Because we're only selecting 3 people total, right? 3 executives total. So always go back to how many total things we need for the situation. Okay, so now I just have to set up each situation, right? 1 woman and 2 men. So there's 4 women. I'm going to choose 1. There are 3 men. I'm going to choose 2. I need both of these things. So I'm going to multiply together. 1 woman and, keyword and, 2 men. And then we have 0 women. And we're going to multiply. And we need all 3 of the men. Now, if you put the 4C0 in your calculator, you're going to get 1. I write it in there as kind of my placeholder. So each time we see the women and the men, each time we're seeing that total of 7 people that we're selecting from. Now, what do I do with those 2 different situations, though? We're going to add them. We're going to multiply them. What are we going to do with those 2 separate situations? We're going to add. Why? What's the key word? Or. Keyword or tells me we're going to add. Because I'm either going to have 2 men or 3 men. I can't have both situations at the same time because then I've selected way too many people. It's either going to be that first situation with 2 men or the second situation with 3 men. And you do a little computation. Did anybody do this? 13? Yeah. Awesome. Now, keeping with that same idea, I want to give you another couple minutes to try part D. Now that we did at least 2 men and we saw the different cases and how we could set that up, I want to give you a minute to go ahead and try the at least 1 woman if you didn't get to before. Or if you did try it, maybe you need to make some changes, or maybe this just reaffirmed that, yeah, I set that up right. I'm going to go ahead and start putting the setup up here. I know some of you are still kind of punching things in the calculator. At least 1 woman means 1 woman, 2 men. Or 2 women and 1 man. Or 3 women and 0 men. So this one just has 3 different situations compared to letter C. And this is an okay way to do it. I know you see that at least. You're like, oh, isn't that something to do with the complement? Yeah, we can. And I want to show you that way as well. It's kind of a little shortcut. So we have 1 woman and 2 men. Or we have 2 women and 1 man. Or we have 3 women and 0 men. Again, that 3C0, it's up to you if you put it or not. I like to just for the placeholder so we can see the men and women each time. Did anybody do that total out?
Yes.
It's 34? Thank you. 34 should be our grand total. Now, there is some extra space. I'm going to go over here. We won't need this space right here. Part 1D. There is a second option. I know when we've worked with at least one before, we've done things with the complement. The difference is when we talked about the at least one and the complement using that, we were working specifically with probabilities. We're not into the probability piece yet. This is just how many ways. You can still use the complement. We just have to find the total number of ways first. So the total number of ways to select 3 people. So we need the total. Again, this isn't our probability, so I can't do a 1 minus thing yet because we're not dealing with the probabilities. We'll get there. But right now we're just dealing with how many ways, and we can still do the complement. So we have to find the total number of ways. So what are the total number of combinations we'd have in our sample space? There are 7 total people. We are going to choose 3 of them. This is just total combinations. Total combinations for our 7 different executives, choosing 3 of them. That will give us 35.
Yeah.
Okay. Now the complement of at least one woman would be how many women? 0. So the total number of ways we can select 3 executives from our 7, there's 35 total ways. The complement, we've talked about this before, but again, it's been specifically with the probability, not just with the total number of ways. Total number of ways is 35. Complement of at least one woman is selecting 0 women. So what that looks like for us would be 4 women, I'm choosing 0. 3 men, I'm choosing all 3. And that comes out to be, should be 1. So we take our total number of ways minus our complement, which is 0 women, and we get the same total. Would I expect you to have done that? Absolutely not. But can it be a shortcut? Yes. Instead of having to find, in this case we were lucky because we were only selecting up to 3 women, so we only had to worry about 1, 2, or 3. What if instead of having 7 executives, what if it was a big company and they had 70 executives? And they were selecting maybe, let's say, 20 people to go. And we wanted at least 1 woman. Holy cow. We would be adding things up for days. So this situation, it looks a little different because we're not at the probability piece yet. But you can take your total number of ways and subtract off that complement piece. It works the same way it does with the probabilities. So it's a shortcut option for you. Obviously, the work we did in letter D, it works. It's just a little bit longer way. So it's kind of up to you. So part 1, we were just finding how many ways. That's what we did yesterday. Now in part 2, I know the setups look the exact same. Yep, I just cut and paste. But now this different situation here is find the following probabilities. So now I'm no longer just interested in, hey, how many ways can this happen? Now I want to find what's the probability that this happens. So if we have all 3 being selected women, probability 3 women, we found the total number of ways we can make that happen, right? We did a little 4C3 and a 3C0, same as our part A. But now if I want to find the probability, I want to take how many times it can happen that I get 3 women, and what am I going to divide by? The total number of possibilities. 7 executives, I'm choosing 3 of them. So this is just the total ways to select 3 of 7 executives. That's all that denominator is. So what we did yesterday was finding the total number of ways something can happen. Now we just have to divide by the grand total and get that probability piece. That's just the next step up. So really today, it really is just the next step from yesterday. We're not doing something totally different. We've been finding probabilities all unit. So the same thing's going to happen for part B and C. Oh, yeah, sorry. Yep, nope, you want to go ahead and do the computation, which we already know from part A, the numerator's 4. And from our little complement piece over here, we know the bottom is 35. So part B is going to be the same situation. It's going to be the same situation as we saw up above. 4 women, we just need 1. 3 men, we need 2. But now since we're finding the probability, we need 7 total executives. I'm choosing 3. Part B's answer was 12. Our total's 35. So again, all we're doing different from the first A through D in part 1, now we're dividing by the total number of possibilities of just selecting 3 executives and getting that probability. That's just the next piece. That's just the next piece. One little thing you can check, if you add together those 2 quote-unquote n values, we called that n, we have NCR. If you add together those 2 n values, you should get the n value in your denominator. If you add together those 2 r values, you should get the r value in your denominator. That's how you know everything is accounted for. That would be a reason why I would keep this 3C0 in there, even though I know it equals 1. 4 plus 3 gives me 7. And then 3 plus 0 gives me that 3. So that's a little way you can check. You can check. All right, with our at least 2 men, it totally depends how much you want to write for this. If you want to just kind of draw an arrow down from your part C, you sure can if you don't want to write everything back out again. 4 women choose 1. 3 men choose 2. 4 women choose 0. 3 men, we're going to choose all 3. Again, this just matches part C up above. If you're like, whoa, slow down, Miss Golly, where are those numbers coming from? Same situation as part C. Now, the nice thing is, and you can do it either way, I think it takes a lot of time to do 2 separate fractions. They're going to have common denominators. So what you can do is you can draw one long fraction bar, do everything in your numerator, get all those combinations in your numerator taken care of, added up, multiplied, whatever you need to do, then divide that total by your denominator. Just make sure You've got parentheses around the numerator. So the division is done last. You need to make sure your calculator is going to do this addition before it does this division. If you don't put the parentheses, your calculator is going to want to divide before it adds. If you have that cool fraction feature on your calculator, you don't have to worry about the parentheses. But I know not everybody has that newer option for the calculator, and that's fine. No big deal. It works. You just need some parentheses. All right, last but not least, the at least one woman. We could, totally an option, we can copy down those 3 separate combinations or situations. We could copy down what's in part D and divide by the 7C3. Totally an option. So I want to show you, though, the shortcut. Probability at least one woman equals 1 minus the complement of that. If this 1 minus thing is still looking really foreign to you for at least, I really recommend getting to the end of the 4-3 practice where you will find practice with the phrase at least. Especially if it's like, hey, I didn't really understand that when we went through it in the lesson for 4-3. Okay, so get to that practice part. But if you don't get to the end of the 4-3 assignment, you won't even touch any of these questions. So make sure you get there. All right, so probability. So this means the complement of at least one woman, and we talked about that earlier, means 0 women. At least one means, in this situation, 1, 2, or 3. Instead of having to find those 3 separate situations and adding them together, consider the complement. The complement is, what's the only situation we didn't consider? And that would be that we don't select any women at all. So that makes things a little easier. 1 minus, I have 4 women, I'm going to choose 0. I have 3 men, I need to choose all 3. Total number of options, 7 executives, I'm choosing 3. 1 minus, what do we get for that complement? 1/35th, 34/35. Keep that in mind with that at least. And I know you're thinking, Miss Golly, that's manageable. I can just do those 3 out. I don't want to mess around with the 1 minus. But like I alluded to earlier, what if I give you bigger numbers? What if instead of 7 executives, we have 70 executives? Instead of choosing 3 people, what if we're choosing 30 people? What if it's a big conference, we're choosing 30 people to go? That's going to be a lot of different combinations to find and add up. Take the shortcut if you can. That's something, again, there's practice. There's practice with that phrase at least at the end of the 4-3 assignment. And there will be practice problems like that throughout today's assignment. So the assignment is at the bottom, guys. The rest of the time is yours. Please keep in mind, not every question you're going to come across in this practice is going to identically match this. There's no way I can go through every situation. We would be here till, like, I don't know, next year sometime. So try it out. Let me know what I can help you with.